In this class, we will see what is the truth table of a full adder. In the previous video, we have already seen what is the function of a full adder and how you can implement it using two half adders. A full adder consists of three inputs which are given to two half adders in this case, as you are seeing in this block diagram, and it performs addition and gives two outputs, sum and carry. So here a full adder consists of three inputs and two outputs as sum and carry. So truth table contains these three inputs and these two outputs which are in a tabulated form. So this is the truth table of a full adder, which is having the inputs as A, B, C and the outputs as sum and carry. As we know very well, there are three inputs and the total number of combinations will be 2 power 3, which is given by 2 power n, where n are the number of inputs. If I am having three inputs, that is 2 power 3, so the total number of combinations will be 8 combinations out of these three inputs. So starting from 0, 0, 0, 2, 0, 0, 1, 0, 1, 0, 0, 1, 1, so on up to 1, 1, 1. These are the combinations of the inputs. Now, if you clearly see B and C inputs, these four combinations are nothing but combinations of the half adder which are considered as inputs in the case of a half adder. So the only difference is another input is considered here, which is a 0 in this case. Now, let us see what is the sum and carry in this case. If now we already know a full adder adds 3 input bits and gives output based on the addition. So in this case, so here the first combination is 0, 0, 0. So if I add this 0 with this second input as 0, so the sum will be 0, and this output is again added with this third input, so the output is again 0. So the sum is 0 and carry is also 0 in this case. Now, considering the second case, 0 plus 0 is equal to 0 and 0 plus 1 is equal to 1. So the sum is 1 without having any carry in this case. So the carry is 0 and sum is 1. So the third case, next case is 0 plus 1 is 1 and 1 plus 0 is again 1. So the sum is 1 but carry is 0. Now the fourth case, which we have already seen in the case of half adder, having two inputs as 1 and 1. So 0 plus 1 is 1 and 1 plus 1 is again, if I consider these two as decimals, so the output will be 2. So here if you see, this combination is 0, this combination is 1, this combination is 2. So in binary, 2 is represented as 1, 0, where this 0 indicates 2 power 0 and this 1 indicates 2 power 1. So 2 power 0 into 0 is 0 plus 2 power 1 into 1 is 2. So the output is 2. So we are representing this as 2 in terms of binary. in terms of binary. So if you clearly see here in this case, this is having a value of 2. So 2 can be represented as 1 and 0. So the first bit here in this case will be the sum, and this is considered as carry. We have already seen in half adder case. So the sum is 0 and carry is 1. So if we clearly see in the table where we can observe a 2-1 combination with a 0 combination, there the same output exists with 2 1s and 1 0. So if you clearly see, this is another case where you are having 2 1s with a 0. So this will also be having a 0 and 1. And this is another case where you are having 2 inputs as 1 and 1 input as 0. So this will be also having the same value as 0 and 1. So our computation got reduced here and here. Now, considering the next case, 1 plus 0 is 0 and 0 plus 0, 0 plus 1, sorry, 1 plus 0 is 1, 1 plus 0 again is 1. So the sum is 1 and carry is 0. Here we have already seen this as the special case which is similar to this case. So the output will be 0 and 1. This is also similar to that of the fourth case what we have seen earlier. So the output will be 0 and 1 again. And this is the last case where we are having 3 inputs as 1s. So 1 plus 1 is equal to 2. Let us say I am considering it as a decimal, and 2 plus 1, let us say this as a 3. So 3 can be written in terms of binary as, see, 1 1 1 1. So 1 1 if I write 2 power 0 and again 2 power 1. So 2 power 0 into 1 is 1 into 1 is 1 plus this is 2. So entire addition becomes 3. So this is the sum value. So I am writing here as 1, and this is the carry value. So I am writing here it as 1. This forms the truth table of a full adder. So if you clearly see, we are having 1s at combination 1, combination 2, combination 1, combination 2, combination 4 and combination 7 for some values. So this is the first combination, 0th combination, let us say 0th combination, first combination, second combination, third combination, fourth combination, fifth combination, sixth combination and seventh combination. So here that first combination, second, fourth and seventh, we are having 1s for sum as the output, and for carry we are having at fourth combination, fifth combination, sixth and seventh. So if we can identify where these outputs are being 1, at which combination these outputs are being 1, we can easily plot a K-map. We can draw a K-map for that, and based on the K-map we can prepare the logic diagram. We can draw it. So this ends the video lecture on the truth table of full adder. In the next video lecture, we will see what is K-map and how we can draw the logic diagram based on K-map. Thank you.